All right, good afternoon and welcome to today's class. Earlier this week we introduced a topic which is indices and logarithm. By God's grace, we have been devouring indices on every side, trying to kill it so that it doesn't kill us. All right, now let's actually take on the counterparts, which is that logarithm. Okay. Now, if you remember, maybe when you are in junior classes or SS1 and thereabouts, you were taught logarithm, whereby you get your four-figure table, going to search for values of numbers, the differences, and so on and so forth. Is that okay? So that type is called common logarithm or natural logarithm. Is that okay? Why? Because that one it has base 10. Its base is 10. Okay, good. Now, but logarithm can be expressed in other bases apart from the usual base 10. So when cases involving logarithm of other bases besides base 10 are being considered, then we're talking about theory of logarithm. That's what we have here. Theory of logarithm. Where because we'll be discussing logarithm that has other bases that are not base 10. Okay. Now the good news is in this topic we're not going to struggle because we have been able to devour indices. Do you know why? It is part of this particular topic. That's why we have to go first and devour indices before coming to this topic titled the theory of logarithm. Is that okay? Good. Now, by definition, normal. Let me use my normal language. By definition, the logarithm, okay, of a number, let's say the number is n, okay, to base, let's say the base is x, all right, then written as log of n to base x, okay. Now it means is the power, okay, to which x must be raised, okay, then to obtain the n. The log of a number is the power, okay, let's say log n to base x, meaning what? It means log of n when the log is in base x. It means the power to which this x must be raised so that n becomes possible or n becomes a reality. Is that okay? Let me just give this simple example. For instance, if log n to base x is equal to a, therefore n is equal to x power a. What do you see now? It means, now let's go back here. Log n to x is the power to which x must be raised to obtain n. The power to which s must be raised to get n. Is that okay? That's the log of n to base a, so to base x. So here say if log n to base x is equal to a, it means that when you raise s to this power of a, then n becomes possible, or n is obtained. Now this is in logarithmic form. This is in index form. You see now, this form is called index form, while this one is called logarithmic form. I'm going to write, this is logarithmic form, while this is called index form. This that index now is not coming back here again. Thank God we have devoured it. Okay, let me give just a few examples, because I just want to get this topic introduced for us to really know the foundation or the basics of it. Okay, now let's take these few examples, just few examples. Let's say one, say if log okay, let me just say 100 to base 10, just an example, is equal to 2. What does it really mean? Mean what? Okay, now let's go straight forward. In this case, what we do is this. I will just say convert this to index form, which is what happened here. Now, which is 100 is the number, is equal to, now the base here, then they become the power. Is that okay? Good. Now let's continue. We're going to work here now. Just, or meanwhile, can just let it be. Yes, because it has now been kind of converted from this to this, from this to this. Okay, let me give another example. Let me just say if log let me use log 8 to base 2. Okay, okay, fine. Now what do I do here? I will convert this to index form. The 8, first of which is the main number, 8 is equal to, the base comes here, then this becomes the power. Is that okay? That was, we just explain here. Let me also give another one, the third example. If log, what do I use here? Okay, let me use log 25 to base 5 is equal to 2. This implies that 25 being the main number is equal to the base power this. As simple as that. Now let me explain one or two things here. Log 100 to base 10 is 2. Log 8, okay, to base 2 is 3. Log 25 to base this 5 is 2. Now we define log as this. Let me take it again. Log of this is this. That of this is this. That of this, it means that this is equal to this. That means log 100 to base 10 is 2. How is it 2? Listen. We define here, okay, that what's it called? Log n to power to base x is the power to which x must be raised to obtain n. That means that power, if gotten, this n is now possible or a reality. Let's come back here now. The power here is 2. This is the power that we need, such that when this base has power 2, becomes 100, then 10 power 2 is 100. Then this 2 now needs power 3 to have this 8, which is 8. 2 power 3 is 8. Is that okay? Now, this 5 here needs 2 as its power so that 25 become possible. That's what happened here. This implies that 5 power 2 is 25. 5 is the base. Then the power is what we are really looking for. Okay, let me assume that, let me just say I say log. What is log? Let me please. What is log 9 to base 3? What is log 9 to base 3? Okay, as simple as that. Let this equal to x, because we need a power, okay, that this must be raised to get this 9. So let this be equal to x. So you can say convert to index form. We now have 9 is equal to 3 power x. Is that okay? At this point, we're going to make the two bases here to be the same. Okay, so that means 3 power 2 give me 9. So I'm going to have 3 power 2, which is 9, is equal to 3 power x. Is that okay? So when I cancel the bases, therefore I have that x is equal to 2. It means that log 9 to base 3 is 2. Is 2. That means 2 is the power to which 3 must be raised to obtain 9. That's all about this particular theory of logarithm. Thank you for watching. Please, I also want to add again, go back, watch the video over and over until you are well satisfied. Thank you.